Welcome Year 9s. We're moving on to a new chapter. We're looking at area circumference, sector area and arc length of circles today. So first of all, let's just review the basics. So question 1a, the area of a circle. Area of a circle is equal to pi times the radius squared, which in this case is pi times, now we've got to be careful because what we have here is a diameter. A radius is half of a diameter. So a radius is any point that goes from the center of the circle to the edge or the circumference of the circle. So in this case our radius is going to be 2.5 squared. So our area of the circle is 2.5 squared pi, which is 6.25 pi. And then we could also give the three significant figures version of that, and that happens to be, if you pop that in your calculator, you're going to get 19.6, I think, centimeters squared. The circumference of a circle is equal to pi times d, or 2 pi r. In this case we're going to use pi d because they've given us d, so it's going to be 5 times pi, and because the diameter is 5, and if we chuck that in our calculators to three significant figures, that's 15.7. This time the unit is a unit of length because circumference is length, so it's 15.7 centimeters. Moving on, question 2. So this time we're trying to do arc length. Now arc length is this bit here. Okay, I'm just highlighting all of the arc lengths now. So the circly bit, those are arc lengths. So let's do the arc lengths first. For A, you notice that you have half of a circle, so it's going to be half times pi d, because pi d is the circumference, and in this case it's going to be half times 15 times pi, and that gives us 7.5 pi, and that is equal to 23.6 centimeters. And B, this is a quarter circle, so we're going to go quarter, oh that's a bit messy, a quarter times pi d, which in this case is equal to 1/4 times 6 times pi. So that's 1.5, isn't it? 1.5 pi, which is equal to, if we round it to three significant figures, 4.71. Now we'll go to C. I hope you can see that this is 3/4 of a circle, so I'm going to go 3/4 times pi times the diameter in this case. Now here's where I've just noticed my mistake from the previous question. It wasn't a diameter of 6, that's actually a radius, so I'm going to pop on a 12 here and correct my mistake right now, which means that everything is going to double. So this will now be 3 pi, and 3 pi is equal to 9.42. So my new answer will be 9.42. So that's a helpful little thing to just be aware of. Make sure you're identifying what the diameter is when you're using this. So this is a radius, this 8 centimeters, so the diameter would be 16. So 3/4 times pi times the diameter, and this will give us 0.75 times 16, 12 pi, which is equal to, that is 37.7. 37.7 centimeters. Now we're going to go back and do the sector area. Okay, so we want area now. Area is just the shaded bits, right? So the orange bits, okay. Well, including that bit there. So that's what we're trying to find now. Now, area of a circle is pi r squared, and these are fractions of a circle. So the first one is area is equal to 1/2 of a circle times pi r squared, which in this case is going to be 1/2 times pi times, and r in this case of course is 7.5. Now what does this give us? 0.5 times 7.5 times pi, you're going to get 15 quarters pi, 15 quarter pi, which is equal to 11.8 centimeters squared. The next one you can see is a quarter of a circle, so we're going to go a quarter times pi times the radius squared. In this case the radius is that 6, so it's going to be 6 squared. Now a quarter of 6 squared is 36, so a quarter of that is 36 divided by 4, which is 9, so it's going to be 9 pi. Now when we put in 9 pi into the calculator, we're going to get 28.3 centimeters squared, because we're dealing with area. The third is a 3/4 of a circle, so we're going to go 3/4 times pi times 8 squared. Now this gives us 48 pi, and if we chuck that into our calculators, we should have 151 to 3 significant figures. 151 centimeters squared to 3 significant figures. Now the same technique applies when we have more complex shapes. This one is not a half, it's not a quarter, it's not 3/4, but you do know the fraction of the circle that we have here. So the whole circle is 360 degrees, so we have 18 3/60ths of a circle in this case. So arc length will be equal to 18 over 360 times pi d. Pi times d, which is 8 in this case because the radius is 4. So what does this work out to be? 18 over 360 times pi times 8. This is giving me 2/5 pi, and that is equal to 1.26 centimeters. Now I'm going to do the sector area, and we have 18 over 360. We're going to times that by pi times r squared. R is 4. We're going to pop this into our calculators, and we're going to get 4/5 pi, and that is equal to 2.51 centimeters squared. Let's carry on. So here we have another one that we need the sector area and arc length. Let's do arc length first. Arc length. In this case, it is going to be, now we've got 315 degrees of our total of 360, so that's the fraction of the circle that we have, times pi times d. D must be 18 since we've been given a radius of 9. Now when we chuck this into our calculators, times 18 times pi, we're going to get 63/4 pi, which is equal to 48.5 centimeters. Okay, now we're going to do the sector area. Sector area is equal to the fraction of the circle that we have times pi times r squared. So we have, what is that? 567/8 pi. Sounds rather strange. 567/8 times pi. When we pop that in the calculator, we're going to get 223 centimeters squared to 3 significant figures. Okay, we'll move a little bit further down here. This one's a word problem. Some of you may have had a bit of trouble. The circular watch has a minute hand that is 2.3 centimeters long. what distance does the tip of the hand move through in 20 minutes? Okay, so let's assume that it starts here. Here's our second hand. It starts here and it moves 20 minutes. So it's moving 1, 5, 10, 15, 20. So it moves to there. Okay? And you know that the minute hand is 2.3 centimeters long. Okay, so it's 2.3 radius, and it's moved this angle here. Now, do we know what this angle is? Well, yes, we do, because the whole circle is worth 360. So we're going to go 360 divided by, and you can see that there's 12 intervals. 1, 2, 3, right? Obviously, because you go from 12 to 12. Okay, so there's 12 intervals. So we're just going to divide it by 12. And 360 divided by 12 gives us 30, which means that each 5-minute interval is 30 degrees. So 30, 60, 90, which you kind of know, right? 15 minutes is a quarter. 90 degrees is a quarter. And then another 30 is 120. So in 20 minutes, we have done 120 out of 3/60ths of the circle. And we want to find the distance that it has moved. So this is the sector area. So pi times d. Now d in this case is going to be double the radius, which is the length of the hand. So we're going to times it by 4.6. So 120 over 360 times 4.6 times pi gives us 23/15 pi. 23/15 pi, which is equal to 4.82. Now B, what area of the watch face is covered by the minute in 25 minutes? Okay, well, 25 minutes, each 5-minute interval is 30 degrees, and that's 5 5-minute intervals, so we've got 150 3/60ths. Okay, so it would be going another one. So this angle here is going to be 150 out of 360. Now we're going to times it by, we're trying to find sector area, so pi times the radius squared. Now what does this give us? Times pi times 2.3 all squared. This giving me 529 over 240 pi, or if I round it to 3 significant figures, 6.2, sorry, 6.92. There we go. Centimeters squared. Yeah, centimeters squared. Seems like a kind of biggish watch. Okay. Right, well that's that. Now let's move on to these compound shapes. Give ourselves some space here. And I'll just pop this a little bit up here. Okay, let's do number 5. 5A. Okay, the area and perimeter. I'm not going to do 5A, I'm going to do 5B because that looks more interesting. You can see that we have let's do the area first, area. We've got a triangle, so that is going to be half the base times the height, half 3 times 4, plus, and then you can see we've got this here, which is half of a circle, half times pi times the radius squared. The radius is 2.5 squared. And then we've got this little circle down here, which is going to be plus half times pi times the radius squared. In this case, it's going to be 1.5 squared is the radius. And then finally, we've got this one here, which is also a half of a circle. Half times pi times, and the radius is 2 squared. Now what happens when we pop all of this into our calculator? What do we get? 6 plus 0.5 times 2.5 squared times pi plus 0.5 times pi times 1.5 squared plus 0.5 times pi times 4. Okay, well, in my quick calculation on my calculator, hopefully I didn't make any errors in doing this. I'm getting 25.6 centimeters squared. Now we're going to do the perimeter of that shape as well. So let's have a look at that. Now with the perimeter, you've got this bit here. So perimeter is around the edge, isn't it? So we can ignore that triangle stuff in the middle. And we know the perimeter of that is pi d, half pi d. So half times pi times 5. Then it goes around this little circle here. So that's going to be plus half times pi times 3. And then we've got this circle here. Plus half times pi times 4. And if we chuck all of that together, what do we get? 5/2 plus 3/2 plus 2. So it's 6 pi. I think it's 6 pi, which is 18.8 centimeters. So the next one, we will do the next one. This is 5c. You can see that we have a square, which means all of those sides are 6. And we can see that we've got a quarter circle, and the radius is 6 for that as well. There's our center of our circle. Let's find the area. Area equals the area of the square, which is 6 squared, so that's this bit here, plus 1/4 pi r squared, and the radius is 6 here. And when we chuck that into our calculator, what do we get? We get 36 plus 9 pi, I think, which is 64.27, or 64.3 centimeters squared. Now we're going to do perimeter. Now with the perimeter, we've got, let's start from here, 6 plus 6, so 2 6s, 3 6s, and then you've got this bit here, 4 6s, okay? So is equal to 4 times 6, and then the last bit, this bit here, is the curved bit, or an arc length, so plus 1/4 of a circle, 1/4 times pi d, and d would be double the radius, which is 6, so double that is 12. And when we pop this into the old calculator, what do we get? We get 24 plus 3 pi, so it should be 33, I think. 33.4 centimeters. Okay, the next one. So if we do the area here, I hope you can see that the area is going to be equal to the rectangle, and you've got 2 half circles. Half, half, okay, so it's just going to be pi r squared. We can add them together. Pi times, now the radius here is 1, because you can see that this here is a diameter. So what does that give us? 6 plus pi, 9.14 centimeters squared. Now the perimeter, what does this give us? Let's have a look. Okay, so you've got this, which is 3 plus 3, so 6. Then you've got half a circle and half a circle, so it's going to be plus pi d, because it's a whole circle altogether. Pi times d, and d is 2. And what does that give us? 2 pi plus 6 is equal to 12.3. 12.3 centimeters. Okay, moving on. Got a few more tricksy ones here. The area of the shaded shapes. We're just working on area now. So for 6a, the area is going to be 28.3 degrees out of the total of 360 times pi times r squared, and r is 6.8 in this case, so we go 28.3 all over 360 times pi times 6.8 all squared. And this is giving me 11.4. For B, you can see that we have a circle. Take away, we've got to get rid of this the square. So area of the circle is pi times the radius, which is 4 squared. Subtract. Now, how are we going to get rid of this square? Well, you can divide it into two triangles. This would be 4, and this bit here would be 4. So we're going to take away two lots of the triangle, half the base, which is 8 times the height, and there's two of them, top and bottom, and that should give us the area of the circle, take away the square. So I'm getting 16 pi, take away 32, and I'm getting 18.3 centimeters squared. Let's move on to C. You can see that you have a rectangle, and we're taking away a half circle from it. Now, if this is a rectangle, you can see that this bit here is 5, because the circle has a radius of 5, half of 10. So we're going to go rectangle, 5 times 10, which is the area of the rectangle, take away 1/2 a circle, 1/2 times pi times 5, which is the radius, squared. What does this give us? 50 take away 25 pi times a half. Pi. Okay, I'm getting 10.7 centimeters squared. Now D again is a rectangle. It's a 25 by 20 rectangle, but you can see you've got a half circle here and a half circle here. So all in total, we've got a whole circle. So we're just going to subtract from that 25 times 20, which is the area of the rectangle, the whole circle, which is pi times the radius squared. Now the radius is half of the 20, so it's going to be 10 squared. What does this give us? 25 times 20, which is 500. Take away 100 pi, which is about 314. So we get in total 185.8, or we could round it to 186 to 3 significant figures centimeters squared. Let's look at E. Now you can see that E is a big circle with a smaller circle punched out of it. So you're going to do the big circle, which is a radius of 5, pi r squared. Take away the small circle, which is a radius of 4, so 4 squared. And that will give you 25 take away 16, which I think is 9. So 9 pi, which is equal to 28.3 centimeters squared. Finally, F. You can see that you have a half circle, take away another half circle. So we get the big circle, which is half times pi times now half of 13 will be our radius. What's half of 13? 6.5. So that's the area of the big circle. Then we're going to subtract the area of the small circle, which is half times pi times 2.5. 2.5 squared. And this is going to give us what is it going to give us? 0.5 times 2.5 squared times pi. I think it gives us 18 pi, which is equal to 56.5 centimeters squared. Now, I know this has been a long video. I hope this makes sense, but if you are unsure of anything, because I was rushing, if you're unsure of anything, please let me know and I can explain it further. Alright then, take care.